Now, for the record, for those of you wondering about a rhombus is going to be treated the same as a parallelogram, or maybe even as a square because of its nature. So think along those lines. Let's go ahead and do a triangle. Now, the triangle is actually the easiest and the hardest. Let's talk about two situations. Let's start off with the easier of the two, which you've been doing since elementary school, and that's the area of a triangle where you have the height and you're given the base. In that case, the area of a triangle is 1/2 times the base times the height. But again, you have to look at what's given to you. So you have to see that the height has been given and that you have the base. So you have to have those two essential things in the right spots. Otherwise, you may not be able to do anything. Just because you have two things doesn't mean you can do anything. You got to make sure you have the right two things. You have to have the height, and it's got to be labeled like that, and you have to have the base. Some of your teachers in the past maybe call it the altitude. Altitude times base or width, whatever. I'm going to show you as base and height. The sophisticated way, which needs to be done if I don't have a height, is what if they gave me all three sides A, B, and C? But notice there's no height. They gave me a base, right? We could say that C is the base, but A is not the height and B isn't the height. The height is going to be something that's perpendicular, and they didn't give me that in this problem. Well, nothing to fear. It looks really intimidating, but it is a simple formula where you just plug numbers in, except you have a simple formula with another simple formula. So here's the formula. The area of a triangle, if you're given all three sides, and this is actually called Aaron's theorem. But it gives us the area of a triangle. That's why this is part of the area of a triangle. So it's going to be the square root of S times S minus A times S minus B times S minus C. It's kind of easy to remember, actually. Might come in handy on some of your SAT tests and ACT tests. So it's S times, if we could put some dots in the middle if you want, S times S minus A times S minus B times S minus C. But make sure the square root goes over the entire thing. And this is a simple task if you're using a calculator, which I need you to use a calculator. Use Desmos. I'll show you how to do a problem here in a bit using Desmos. But you should be asking me at this point, Mr. Trevor, what the heck is S, right? It keeps showing up. Here's S, and here's S, and here's S. But I don't see any S right here. Well, let me introduce you to my friend, semi-perimeter. So in order for this formula to work, you have to do another little formula on the side called a semi-perimeter. So you have to take these numbers, A, B, and C, and you add them up. Add them up. Use Desmos to add them up, or a calculator to add them up. And then take them divided by 2. Now, let me point out two important things that students mess up on. This is a very simple process that's mechanical and requires minimal thinking, but it requires you to keep track of a lot of little things. So, first thing that people usually goof up on. 1, they forget to divide by 2. So, take first step 1. If you want to pause and write down words, this is a good opportunity to write down words. Step 1. Before you even do that, the title of this, right? How to find the area of a triangle if I have all three sides. Step 1, let's begin. Add A plus B plus C. Step 2, divided by 2. Step 3, take that number and plug it in here for every S you have, and then plug in the A, the B, and the C, and the right spots. And then finally, step 4, put this thingamajigger in a calculator and let it do its thing, and then pump out the answer. Now, granted, yeah, that sounds a lot more to do than just this formula. Mr. Rover, I want to use this formula because it's a lot easier. I don't blame you. But the problem is, if it's not something that you can use, then it's something that you can't use. So if they don't give you the height, like this problem, right? We said this is the height. If they don't give you the height then you can't use this formula right here. This formula requires you to have the height. So make sure you make a note to yourself that this requires us to have the height. Not only that, but also the base, right? Okay. If I don't have that and they want the area of a triangle, well, I better have all three sides so I can go ahead and do the hokey pokey. And we'll show you an example with it. So just to recap all that craziness, the formula is square root of s. That's an s. I know some of y'all haters hate my s's. That's an s, not a 5. That's an s, not a snake. That's an s, not an illness. S times parenthesis s minus a, parenthesis times s minus b, parenthesis times s minus c. And y'all better put this parentheses in there, and y'all better see that square root go all the way across. Okay? That's the formula that'll give you the area. However, before you do that, make sure you find the semi-perimeter. A plus B plus C divided by 2. Those of you wondering what the semi-perimeter is, yes, it's related to the perimeter. The perimeter is the distance around the edge of the polygon. In this case, the semi-perimeter is halfway around that edge of that polygon. We're not going to talk about perimeters. We're focusing on area, okay? Folks, problem 2 is going to make you feel like a mathematician because this is going to be like the best proof you've ever seen. Ready? Ready. We're going to use a rectangle to prove the area of a triangle. What? Yes. So here's a rectangle. Check. Instead of length and width, I'm going to call this base and I'm going to call this height. So we know that the area of this shape right now is base times height. Correct? Because it's a rectangle. We do the length times the width. There you go. Okay, get ready to be amazed. What if I cut this rectangle in half? Oh snap, did I just cut it in half? I did. What did I make in the process? A triangle. Oh, so a rectangle is half of a triangle? Yes, yes. That was a proof. You might have to go back and replay that. Okay? It's a proof. Try it out. Show your siblings. Show your parents. Show the world. Spread the gospel. What we did is we took a regular rectangle. We cut it in half. But don't cut it in half like you would a hamburger or a hot dog, right? Cut it in half like you might a fancy sandwich, diagonally. And by doing that, we show that half of a rectangle is a triangle, which means half of the area of a rectangle is the area of a triangle. The proof for the area of a trapezoid will be left as an example or a problem for you to maybe do in one of the quizzes. But for now, let's tell you what it is. So if we have a trapezoid, right, we have a base 1, B1, and a base B2, and we have to know the height, right? The height, of course, is that perpendicular. If we know that, then the area of a trapezoid is h times parenthesis b1 plus b2 over 2. Sometimes is written as 1/2 h b1 plus b2, which you might see later on. Either one is fine. I personally prefer this one because we have less things to deal with. We just do the numerator and then divide by 2, and then we get a result. So let's do a few little tiny mathematical problems. Here is an interesting picture which is going to be very important to us later in the future. But here's a big square. You see the big square right here. And then you see little triangles. They happen to all be congruent triangles. And then there's a little square, a smaller square to say, inside. We should definitely, with diagrams like this, we should definitely label everything that we can. So this is A, this is B, this is A, which is the same as A. This is B, this is A, B, and A. And if this is a square, C and C, then this is also C and this is also C. Now there's a lot of A, B, C's here. And in the future, this will help us to prove something called the Pythagorean theorem. But for now, let's go ahead and just do some little math here. If A is 3 and B is 4, what's the area of a triangle? So if A is 3 and B is 4, here is one triangle, for example. What is the area of that triangle? Well, it would be 1/2 times the base, which is 4, times the height, which is 3. And that's going to be 12 divided by 2. 4 times 3 is 12. And that gives me 6. So the area of each triangle is going to have an area of 6. That's 6, 6. So that's the area, right? Remember, the area is me coloring the inside of this shape. It's the interior space of this shape that is bounded by the sides of the shape. How about this square? If one side is equal to 5, well, the square is going to be just the side times the side. That's 5 times 5, which is 25. For your summary, explain in words how the area of a triangle is related to the area of a rectangle.